Good afternoon, everybody. I am going to take the seminar about the flip-flops of second unit. So I am Jayashree, Assistant Professor, BM from the Department of Biomedical Engineering. So let us see the flip-flops. There are different types of available. There are different types of flip-flops available. Let us see the D flip-flops. So flip-flop is a single bit that is used to store the single bit. It is a combination of registers. Let us see the truth table of the flip-flop. It is a modified D flip-flop is the modified form of SR flip-flop. Here it is what this is what the truth table of SR flip-flop, which is what if set is 1, the output is 1. That is what indicated by the row 4. If set is 0, the output is 0. It is what if reset is 1, it will reset the output to 0. That is what here if set is 1, the output q of n plus 1 is 1, and if reset is 1, the output is 0. Next, let us see how it is constructed. This is what D flip-flop construction. In order to overcome the shortcoming of RS flip-flop, the D flip-flop are designed. The D flip-flop is the most important of the classical flip-flop, as it ensures that inputs S and R are never equal to 1 at the same time. This is what the D flip-flop block diagram and circuit diagram, which is what the D flip-flop is single input and clock is given. Q and Q bar are the two outputs, which is represented by the right side of the block diagram, and SR flip-flop, which two inputs S and R are clocked together to form the two inputs. That is what which is represented by data in, which is inverted. One input is directly connected to the block diagram, and the other input is inverted to the second input of the circuit, which is what the NAND gate circuit diagram. Next, this is what the truth table of the D flip-flop. When clock is 1, the D input is 0, the output is 0. Whenever the input is 0, the output is 0, irrespective of the clock. So first, third row, when clock is 1, the input D is 1, the output is also 1, which is what the representation of this truth table of this D flip-flop. When clock is 0, it shows the previous value of the output. Next, characteristic table equation. So this is what the characteristic table equation of D flip-flop, which is same as to SR flip-flop with slight difference, where in SR flip-flop there are two inputs are there, but here only one input, Q of where Q is nothing but the previous state, and Q of n plus 1 is the next state. 0, 0, that is if both the inputs are 0, the output is 0. That is previous state is 0, D input is 0, the next state is also 0. If clock is 0, that is previous state is 0. If D is 1, the output is, the next state is 1, which is indicated by the row 2. When previous state is 1, the D input is 0,